Hello everybody, today we're going to start our first day of notes. I apologize if the volume on this is not great. This is the first time I'm using this new computer. And just fair warning, you might hear my dog in the background. He likes to make an appearance sometimes. But we're going to go ahead and get started. Today's notes are on operations, specifically the order of operations. So we're going to talk a little bit about that. Most of this should be a review for you, so it shouldn't be that long of a video, okay? So, and I feel like you could probably see all this stuff that's actually going to click up in a second. So, first thing we're going to do vocab. An expression is a mathematical sentence. Pretty easy. It's just like, it's math. The only thing that's special about an expression is it does not have an equation in it. It doesn't have an equation. It doesn't have an equal sign in it. As soon as it has an equal sign, it's now an equation, which is something different. So it's just basically an expression is a bunch of numbers and operations with no equal sign. A numerical expression is just a mathematical sentence containing only numbers, so there are no letters involved. Once we start to involve letters, that's called algebra, so we'll learn about algebraic expressions next class, or next video. By the way, if at any point I'm going too fast, feel free to pause the video so you can take your notes. If you miss something, you can rewind, all that fun stuff. That's the beauty of a video. Okay? Simplify means that we're going to perform the operations, and our goal is to get a numeric value. Currently, with today's notes, we will be able to get a single number as our answer. Later on in other videos, we're not going to be able to because we're going to start adding in those letters. So when we say to simplify, we're trying to do as many operations as we can to get it as simple as possible. Order of operations is, it's the order that we perform these, I can't say this word, arithmetic, which means arithmetic. It's arithmetic operations. Wow, Miss Scully, you're great. So it's the universal, agreed upon order that we perform operations in. And I'll give you, an anagram so you can, remember the order and all that stuff. But we're going to do the order of operations today. And then lastly, our grouping symbols. So it's actually the very first thing that we would do in order of operations. There's symbols that contain an operation. When we have grouping symbols with an operation inside of it, it means that needs to be done first, because we can't do anything with that group until we get a numeric value for it. So we have to find that numeric value first, and then we can perform the other operations outside the grouping symbols with that number. Okay? So here is the order of operations. You guys might have learned it as PEMDAS, but now we're calling it GEMDAS. Okay? GEMDAS. And we start with a G now because we're not just talking about parentheses, we are talking about grouping symbols. So that does include the parentheses. It also includes brackets, braces, absolute values, radicals, and the fraction bar sometimes. Okay? Something to note about grouping symbols, though, they're only done first as long as they have an operation inside. So just because you see a thing of parentheses does not mean that's automatically a grouping symbol, because sometimes parentheses are symbol multiplication, and sometimes fraction bars just have a 2 and a 4 over it. When that happens, it's not a grouping symbol, because in order for it to be a grouping symbol, it needs to have a group, not just a single number. So we usually look for operations inside that we need to perform. So then when we see that operation, we perform that group first. You guys can't see it, but my hands are moving all over the place. We perform that group first, and we do that operation first so we can get a numeric value. Then we can go ahead and work with everything else. Okay? The next step is exponents. Anytime you see an exponent, you want to go ahead, and you dealt with all the grouping symbols first, you want to deal with exponents next. Okay? Because it's kind of again, we want to simplify. So 3 squared, it looks like a 3. It's kind of like a number in disguise. It's not. It doesn't really mean 3, though. It's 9. So we want to get that out of the way and have it actually equal the number that it actually means, not just this operation that's going on. So we want to get rid of any exponents next. The next step is multiplication and division. So they're lumped together because when we have multiplication and division, the only rule is that you just perform either of them when you read left to right. So like we normally read across the math sentence, if we see multiplication or division at this step, we just do it as we see it. Okay? So whatever comes first when you start reading left to right, that's what you do, either multiplication or division. Okay? The next one is addition and subtraction, and same thing. You can perform those in the same step. It's just whichever one you read left to right. That's how you go. That's the order of the addition and subtraction you do first. Okay? So GEMDAS. It's written on the wall in the room, right by my desk. So you don't have to try to, well, you should memorize it. However, if you forget, it's right there. So, GEMDAS. Alright, now let's put it all together in an example. Example 1, simplify this. So we got 15 divided by 3 times 5 minus 4 squared. Now this one doesn't have any grouping symbols, so we can skip that step. The next step is exponents. So we're going to do this 4 squared first. Okay? Everything else we're not going to touch except the 4 squared. We're actually going to write out what that's equal to. So 4 squared is 16. So now it looks like 15 divided by 3 times 5 minus 16. The next step would be the multiplication and division. So here's our multiplication and division going on right here. Okay? Because division comes first when we read it, we're going to do 15 divided by 3 first. 15 divided by 3 is 5. So now it looks like 5 times 5 minus 16. Now I can do this multiplication. 5 times 5 is 25. And then I can just do the last operation, which is subtraction. 25 minus 16 gives me 9 for my answer. Okay? So now you guys are going to try this one on your own. Okay? It does have every step. Yeah, it does have every step in it. Okay? So give this one a try. You can just pause the video while you work on it. And when you're done, go ahead and unpause the video and we'll move on. Okay? So go ahead and pause the video now. Alright, so hopefully that try on your own wasn't too bad. But let's go ahead and look at something else. What about the fraction bar? Okay, this is a weird question. Fraction bars, sometimes grouping symbols, sometimes not. Remember I said, it's a grouping symbol if it has an operation in it. So let's look at some examples that the fraction bar is a grouping symbol. And what that actually means, because you're probably like, what the heck are we talking about? So here are 2 examples where the fraction bar is a grouping symbol. What we mean by making the fraction bar a grouping symbol, all it means is that you must simplify the top and the bottom to a single number before you can actually do that division that's represented by the fraction bar. Okay? So you need to simplify the top and the bottom before you divide, and if you can't divide because it's not even, before you simplify your fraction. Okay? So all this, for the second example, we would want to simplify this top one first. You don't need to worry about the bottom because it's already a single number, but we're just going to take care of this absolute value up here first. Okay? Do the top first. So I'm just going to rewrite this numerator. That's what the top is called, the numerator. I'm going to rewrite the numerator just down here so I have room to work. The absolute value of 6 squared divided by 3. And here is where my absolute value symbols are a grouping symbol because I've got a couple of operations in here. I got an exponent and I got division going on. So now, because it's a grouping symbol, I want to do that first anyway. But inside my grouping symbol, because I've got multiple operations, I still follow GEMDAS. So here I'm going to do the exponent first. I'm going to do 6 squared. 6 times 6 is just 36. So now it becomes the absolute value of 36 divided by 3. Now I can do the division. 36 divided by 3 gives me 12 inside the absolute value. Now that I have a single number in here, I can actually take the absolute value. I can't take an absolute value. I can't take a square root. I can't do division with a fraction bar until I have a single number. Okay, so because I have the absolute value of 12, I can go ahead and take that absolute value. The absolute value of 12 is just 12. So I'm going to put that back over our original 9. So now I have 12 over 9. Okay, now is when I can do the division. Okay, so 12 divided by 9 actually gives me 1.33 repeating. In algebra, we don't really use decimals very much anymore because like the decimal skill was more of an elementary, early, middle school kind of skill. Now we go ahead and just leave it as an improper fraction, but a simplified improper fraction. So I'm going to go ahead and simplify this fraction. 12 over 9, they're both divisible by 3, so I go ahead and divide them both by 3. It actually gives me 4/3. Okay? So 4/3 would be my final answer. I'm going to go ahead and have you guys try this one on your own. This one's a little bit harder than the example because you have to do the numerator and the denominator separately, and then you can put it back as a fraction and deal with the fraction. Okay? So go ahead and give that one a try. Just pause the video. When you come back, we'll move on. Okay. And we'll go over the answers to try on your own in class next week. So don't worry. We will go over it before we get into more practice of this stuff, okay? All right, example 3. Waldo simplified an expression. So here someone's already done all the work, but it says he did it wrong. So we're going to find the error and then simplify the expression correctly, okay? So here's the operation he started, or not the operation, the expression he started with. Okay, we got subtraction, multiplication, and an exponent. According to GEMDAS, we do the exponent first, which is what it looks like he did here. Everything else stayed the same. He did 3 squared, got a 9. Okay, so now we have subtraction, multiplication, addition. Next thing in GEMDAS would be the multiplication. He would need to do the 8 times 2. It doesn't look like he did that here. He did the subtraction first. So that's where our error is. He needed to multiply first, but he decided to subtract first. Okay? What he should have done is the 8 times 2, which would have given 23 minus 16 plus 9. Then he could do the subtraction, which gave him 7 plus 9, and then he can do his addition, giving us 16. So the order really does matter because we got very different answers. Okay? I followed the order of operations, and I got 16. He did not, and he got something different. Which one do you think is right? Okay? So Michaela's looks like she did something similar. I want you to go ahead and take a look at this and try to figure out her mistake and correct it as well. Alright, so last example. This is just with a lot of steps going on at once. Okay? You still follow GEMDAS with these 2 examples, okay? It just looks horrible because there's a lot more stuff going on. It's okay, though, because we still just follow GEMDAS. We take it one step at a time, alright? So actually, I made a mistake when I printed these. Go ahead and scratch out the divided by 3 part. It doesn't actually work if we do the divided by 3. I want you to take that out, okay? So, and we look at it, we got negative 3 plus 5 times the cube root. This is the cube root, okay? Cube root of 32 minus 5. Alright? Now, we've got parentheses inside this square root, or cube root, so we're going to do the parentheses first. When we have multiple grouping symbols inside of each other, we work from the closest one, the most inner one, out, okay? So I'm going to work with these parentheses first. So 32 minus 5, that just gives me 27. Again, scratch that out. So now I have negative 3 plus 5 times the cube root of 27 all over the absolute value of negative 4 plus 2. So now that I have nothing in that square root, I'm going to go ahead and simplify that. And just take care of it so I don't have to worry about it anymore. Just finish that whole group. Cube root of 27 is 9. So I've got negative 3 plus 5 times 9 all over that absolute value. So addition and multiplication. Multiplication comes next in GEMDAS. So I go ahead and take care of that. 5 times 9 gives me 45. So negative 3 plus 45 all over negative 4 plus 2. Okay, or the absolute value of negative 4 plus 2. Now I can do the addition on the top. Negative 3 plus 45 gives me 42, all over that absolute value. So I've taken care of the numerator now. Now I need to make the denominator a single value. So I'm going to do negative 4 plus 2 inside that grouping symbol of absolute values. I get negative 2. Now that I have a single value, I'm going to go ahead and take the absolute value of that. The absolute value of negative 2 is just 2. So I get 42 over 2. I can actually divide this. So when I divide it, I get 21. Okay? Literally one step at a time. Alright? And this is your last try on your own. If you have any questions throughout all of these notes, please make sure you write them down next to the question so that when we go over it, you can ask them in class. Otherwise, we will go over these try on your owns and give a little more in-depth practice with it before moving on to our next topic. Okay? I will see you guys next class. I'm not going to say goodbye yet because I don't have the recording up. Other than that, I'll see you guys later. Woo. Bye. Bye.